In this video, we'll complete the Review 2 packet, and we are working on Unit 0, page number 16, the last page on the packet. So we are doing Review number 2, open-ended problems. Okay, let's continue working on number 16, 18, 22, 23. Question number 16. A rancher wishes to enclose a rectangular corral with 320 feet of fencing. The fencing is only required on 3 sides. Rectangular. So 1, 2, 3 rectangular here. Okay, existing stone wall. Okay, stone wall. So let's say this is rectangular shape. So if I go with this as x, and the other will be y, but having two variables in one equation is not a good idea. So let's think about using number 320. So 2x and this y all together makes 320, right? So can you solve for y? Yes, 320 subtract 2x, right? X and x together 2x. So if I use 320 minus 2x for this unknown, and I can use everywhere with only one variable. If I have one variable, I need only one equation to solve it. So if there is an option, I can rewrite it with the same variable x and then have same variable for every place. So let's think about what's the dimension of the maximum area. So this is the area, right? Area is going to be a function of x, right? So let's start with area. What is the area formula for a rectangular shape? Length times width. What's the length? Either one, right? So x times 320 minus 2x, that is the quantity we are multiplying. So that's width and this is length, and together that is the function. So let's simplify. Negative 2x squared plus 320x. I distribute x and I list them in descending order. Does it make sense? What kind of parabola is this? Upside down parabola like that, right? So if I'm looking for the dimension of the maximum area, since this is the area formula function, and I'm looking for the vertex, right? That vertex gives us the maximum area. So what is x coordinate? And then if I know x coordinate, and I can answer what is y, and by using x and y in dimension, and I can answer the question. Make sense? All right, so let's use a calculator, or you can just find the vertex quickly. Can we do the vertex form? So let's change this standard form to the vertex form. So negative 2 will be isolated. If I take negative 2 out, half of 320 is 160, right? Okay, I'd like to make perfect square here. So let's think about what is the half of this number in the middle. Half of 160 is 80. So I need I need 80, and then I'm going to put second power outside. That's going to be the next step for completing the square, okay? So let's think about going back. 80 to the second power, what is the number? What is 80 to the second power? 8 times 8, 64, right? Okay, 1,000. All right. If I add this number because I needed it, I must subtract it. Okay, I must subtract it. So we can equate everything same as it is. Make sense? So take away the same number I added, is same above, right? And next step, I need to use these three parts for completing the square. So I'm going to expand this one, taking this part outside. So I'm going to take this outside. Two negatives make positive, plus twice over this number is 12800. So this is called a vertex form. Vertex form. Vertex is at 80, 12800. What is the meaning of this? This is your x coordinate and this is the area. Okay, so what is the dimension? I need x and y, right? So what my x is 80 and what is my y then? So let's plug this in the y expression and then let's evaluate it. So 320 subtract 160, that is 160. So x is 80 and y is 160. So dimension will be, we usually go with the length first, right? So 160 by 80. What is the unit? Feet, right? So I can say 160 feet by 80 feet, and that's going to be the dimension over this problem. So we are using quadratic function to find maximum minimum case. By looking at the extrema, we can tell the maximum or minimum in the work. So here, little difficulties, right? Because you have to use completing the square technique. And we got the vertex, or you can graph it on the graphing calculator, but zooming out or having a good X, Y boundaries for the graphing on Windows, so you can use all the numbers correctly, okay? So think about real life situation, and number is not from -10 to 10, so you need to use good numbers to see all the graph on one window. So change the numbers to see all the thing and use the button for the extrema and find X value, find Y value, and answer the question. Any questions? Question number 15 is talking about completing the square technique, okay? So 15 and 16 together, review the quadratic functions. Question number 18. In Algebra 2, we talk about polynomials a lot, and now we are looking for a polynomial function with the real coefficients that has zeros like that. So let's write this in factored form. So let's name function as f of x. And first, the 0 is 0, so I can say x minus 0, or I can just say x, right? Who's writing x minus 0 as a factor? So let's go with x. From 0, I have x. From the next number, 3/2, I have x minus 3/2, right? And last one is, what is that? Is that I? Imaginary number I, right? Okay, imaginary number I, so I have x minus I. If I expand this polynomial, I'm going to have a imaginary number as a coefficient, right? It doesn't make real coefficient. To make this as a real coefficient, what is the idea? That's right. This one goes, and then I need to use its conjugate. Negative I and positive I, they are conjugate to each other. So I'd like to have those together. Okay. How about 3/2? Is it okay? Is that a real number? Yes, that's a real number. It's a fraction, but that's fine. So this will be the simplest polynomial function having all three solutions. Ms. Zhang, we have 4 solutions. Yes, that's right. But it's okay to have 4 solutions because we include those 3. Okay, we need to make real coefficients. And now let's simplify. So first 2, what do we get? Let's multiply that way and then multiply one more time, okay? So distributive property, x squared minus 3/2 x. Would you like to double it to make everything with integer? That's a good idea. That you can do that too, right? If you don't want to carry 2 in the denominator forever, you can double it. That's fine. Anyway, next one. What would be the equation? X plus I, x minus I. First, outer, inner, last, 4 method. What do we get? sum of two squares, right? X squared plus ix minus I squared. These two canceled out. I squared is -1. Negative of -1 is +1. So sum of two squares can be factored with the imaginary numbers, right? So that's it. Next step, would you like to expand all of them? Yes. Annoying having 2 in the denominator, right? Can I double it? So we can go easily. Yeah, why not? Let's do that, and then let's double that. So this will be 2x squared minus denominator 2 canceled out, so we have 3x, and the other part will be like this. Let's expand all of them, and that will be the answer in the simplest one, okay? Without fraction, without imaginary coefficient. So that will be 2 times 1 is 2. X to the 4th power, right? Outer second power, inner third power. So let me go with the inner first, third power. Outer will be positive 2x squared, and the last one, negative 3x. And that will be the one of the equations. Is this only answer? No, it's not only answer, okay? We found a polynomial function. There are infinitely many, right, cases. So you have multiple of this, or you don't have 2 times 2, so we can consider everything as an answer. Make sense? Okay, so we talk about root relation on the polynomial functions. Question number 22, quadratic formula. So let's review quadratic formula briefly. This is A, this is B, this is C, and it is in standard form, ax squared minus bx plus c equals to 0. What is the formula? Draw the line along with the x equal sign, okay? And negative b plus or minus square root of b squared minus 4ac all over 2a. That's the formula. All right, let's plug in and let's evaluate it. What is negative of negative 2? Positive 2. Let's square the number. 2 times 2, that is 4. Or negative 2 times negative 2, that is still positive 4. And minus 4, A, C. I always write numbers because I don't want to make mistake there, okay? 2 times 5, which is 10. All right. Now let's look at the next step. Oh, 2 plus minus. Okay, what do we get for the multiplication? 4 times 5, 20. Times 6, 120, right? That's negative. Add 4, what do we get? Negative 116, isn't it? Negative 116, all over 10. Do you get the same thing? Can we simplify negative 116? Can you simplify that? Okay, we want I at the end, right? How about simplifying radical square root of 116? 116. Factor by what? 2? 58. 58. What is half of that? 26. What is half of 26? 13. That's it. So this is the product, right? So which one repeat twice? 2. So let's take 2 out. 2 out. And what's inside then? 2 times 13. 26 is still inside. So this can be written as 2 plus or minus square root of 26. I at the end. Wait a minute. 2 square root of 26. I at the end all over 10, right? Now let's look at all numbers at the same time. These are rational numbers, rational part from this irrational. All right, I need to fix something. Okay, this is not 26. F of 58 is 29. So it cannot be done any longer. So we have 2 root 29, right? Okay, so that's thing. So let's fix that part here. All right, so final answer will be 1 reduce 2 and 10 from the rational part. So 1 plus or minus square root of, here's invisible 1, and 29 in front of I all over number 5. So we have two imaginary solutions for this quadratic formula, quadratic function. Is there any other mistakes? Okay, so here's the quadratic formula. Plug the numbers and simplify the radical with the imaginary number I and then reduce it. Now let's do number 23. Let's factor. So f of x can be factored with difference of two squares. So one will be plus 4, the other is negative 4 with the second power, right? Can you do more? Yes, we can do more. If I keep the first part as it is, it's not going to be a linear factor. So I need to factor all to degree 1. That's the direction, okay? Linear factors. So can I factor this further? X here, X there. 2 times 2 makes 4, right? But number will be plus 2i minus 2i. I must use imaginary number to make sum of two squares. The other one is not, right? Difference of two squares can be factored in real number system. X plus 2, X minus 2. So this is difference of two square, and this is sum of two squares with I. So that is factored form, and all of them has degree 1. So we have 1, 2, 3, 4 linear factors. So we will have 4 solutions for this function. Okay.